Hello, everyone, and welcome. My name is Asya Shklyar. I have 20 minutes and 21 slides. I tend to speak pretty fast, so I'm going to try to get through all the slides in less than 20 minutes and then pop out for some Q&A. But if that doesn't happen, and if I do take up all 20 minutes, my LinkedIn information is at the bottom of the slide. Feel free to reach out to me afterwards. I'm happy to answer any questions. So my talk today is about high-performance computing and research support at a liberal arts school. And I just gave this talk a few weeks ago at something called Virtual Residence, where it was a group of about 600 people, researchers and people that support researchers at academic institutions across the United States. And I added this qualifier for this slide deck because I feel like this is the audience that can appreciate my experience, and I would like to share it with you and then maybe have a conversation about how we can change it. So a little bit about me. I've been in IT for more than 20 years in various roles since '95. I've worked at startups, large corporations. I've done consulting, and I am now working in a higher ed institution for about 2.5 years. Pomona College is located in Claremont, California. The picture on the bottom is the art installation right outside the IT department by James Turrell, who is an alum of Pomona College. It's called Sky Space, and it changes colors at night when the sun sets. I'm the director of high-performance computing, which is a really niche job. Basically, I like to explain it as when you need more than one computer. That's probably when you need to talk to me. Pomona College is a little bit unusual because it's an undergraduate school, but that also does research. So I support both research and teaching. Sometimes they overlap. I also founded a technology exploration lab. To learn more about HPC at Pomona, you can go to hpc.pomona.edu, and I'm also trying to be active on our Twitter account, Pomona HPC, so tweet at me. The painting that you see is of me some years ago, made by someone who didn't know me very well. That is more likely to be beer. And also, I don't quite look so casual. I'm usually a lot more intense. And I'm holding a graphics card in my hand because that's the workhorse of high-performance computing these days. That happens to be a 1080 Ti that I'm installing into an external GPU. So part of my talk is going to be technical, and part of it is going to be reflection. And I'm kind of curious to hear your reactions about how this is going to go. So this is my path to where I am today. I did not have any access to technology of any sort till about 17 years old. And I don't count the construction director set and a Sony tape and then CD player as technology. But we had no car, and I didn't have access to any electronics or anything technical, really. And then at around 17 years old, I got thrown into a project to help out a friend of my dad's to assemble a network. Star topology back then, work with databases, like B-tree databases, and come up with some web presence. This is the era of Red Hat 4 and DOS 6.2. Maybe some of you in the audience relate to those words. And this seems complicated, and this was an unusual situation. Everybody around me was too busy with their real jobs, so this was kind of a toy. And so I built all of this without really knowing how much usually goes into learning about it. And then I migrated between continents because in the 90s, there was a startup boom and the US lacked IT talent. And I came to the United States on parole visa. It's a really curious thing. No one really knows about it. If you Google it, you'll find more explanation. And I didn't really notice the startup crash because I've always had skills that were in demand. I've never been without a job, fortunately. I decided to stay in IT despite the constant distrust and judgment because I enjoy solving difficult challenges. And I just had a conversation with my partner the other day where he tried to convince me I'm successful, but I still find myself thinking that I don't belong or I'm not sure I belong. A little bit about my other identities. I'm an Exceed campus champion. Exceed is an infrastructure shared among academic institutions that provides access to more computing and storage capacity than you have access to. And there's a lot involved in that, education efforts. And there's also something called Empower program that pairs mentors and mentees, not necessarily at the same institution. So I've done that. There's a conference that we get together at every year and share our experiences, practice and experience advanced research computing. I mentored at the conference as well, and I'm still in conversations with my mentee from Chicago area. Last year, Pomona College hosted Snap the Gap event, which was meant to bring 10 to 20 girls. We actually ended up hosting a group of 20 into STEM and STEAM and change their mind about being engineers. Majority of them came in not thinking that they can be in any technical role, but I think we succeeded after about 10 sessions of mentoring them that it's possible, and we got them excited, and that was very rewarding. I participated in big data and data science meetups because it's a constant source of education. I never think that I know nearly enough. I mentor my coworkers who are curious about what I do and want to learn and help. I also help artists in Southern California learn about technology and how it applies to them. And there's a conference called Southern California Linux Expo. I spoke at that conference as well. So what you see here in the pictures is Zintan. That's one of the students at Pomona College that I mentored, and he also became a campus champion. He went to a boot camp at San Diego. He was the only undergraduate student there among a bunch of PhDs. But learning about high-performance computing and how to use this technology effectively as a graduate student or a PhD is too late. You really have to start earlier. So Zintan is proof that the efforts work. And on the bottom, you see a picture of a girl from Snap the Gap program and her parent surveying her creation, which I believe had a sensor counting the balls that were thrown into the plastic cups. And then I have a couple of pictures. I was reminiscing about my experience at conferences. Those of you who had been to technical conferences know what I'm talking about. And so this picture is about me in my natural habitat, so to say. I notice a thing, like a rock, and I'll see something about it no one else sees, and I'll take a picture and I'll think about it, and then something interesting comes out of that experience. And so there's another picture, which is a post-conference day full of activities. The only woman. I'm excitedly talking about something technical. Don't quite know what, but everybody's listening and paying attention. And I realized when looking at this that when that picture was taken, I was not aware of the fact that I was the only woman in that group. That came way later, and I'd like to change it. So it feels pretty lonely when you realize that you're the only one in the group, and even not considering how you're not listened to, or how you're sometimes shut down or ignored, and your opinion is not considered valid. But it's a lonely experience. I would like to see more women in technical jobs. Switching gears a little bit, I'm going to tell you about Pomona College infrastructure, and the pictures are of our data center and the students, and I like to give them tours. So we have about 1,000 local cores. We use Exceed, we use cloud. I do not engage with that conversation of moving everything to cloud. In fact, I moved some researchers out of cloud because that became too expensive. It was funded by a grant, grants expire. When I was building infrastructure, I made the decision to make it diverse. So I didn't get 10 of the same thing. I got all the unique technology that was available at the time. The highest amount of cores in a single 2-socket server, like AMD's EPYC, which came out at the time. And then the 28-core Skylake from Intel. And of course, comparing how AMD and Intel work with different software. And then NVIDIA cards, Pascal generation P100 was a staple at the time, and then Volta came out, so we had both P100 and V100. And of course, the Volta architecture became very useful for artificial intelligence and inference workloads. And we got really expensive flash storage for bioinformatics type workloads that are really high in I/O usage. And we're experimenting with Minio as an on-premises cloud storage, and also it's pretty good performance for most workloads. We are using Slurm as a scheduler for jobs and experimenting with Kubernetes for scaling things like GitLab and doing auto grading for a computer science professor. We are using R and RStudio, both desktop and web-based versions, which is capable of submitting jobs to our HPC infrastructure. We are also using Jupyter in all of its iterations, Jupyter Hub, Jupyter Lab, and we try to support all the researchers and recognize that their workflow is comfortable to them, and there's got to be a way to convert what they're doing on a day-to-day basis into something that's more scalable. So that's part of my job. The primary languages that we work with right now are Python, Scala, and Julia. And this is a slide I stole from another presentation I gave about the lab. And to explain to you why the lab started, I'm a geek. I like playing with technology. I have basically the same setup at home, and I wanted to share it with the students, especially students that come from the backgrounds that did not have exposure to technology. And also, I thought of it as a way to make learning about Linux, command line, and my actual job more fun. Because when you're having fun, you kind of forget about the complexity of the task. So this is a little bit of what we have in the lab. We have 3D printing, we have virtual and augmented reality headsets. Students get very excited about the fact that they can custom 3D print things for their dorms. And also, it's hard to just choose one technology. You kind of have to consider all of them together. So we do comparative analysis of tethered and wireless headsets and 360 and 180 cameras. We're looking at 3D scanning technology, and we built a library of educational resources that can be used to learn and then apply that knowledge. Another lab slide where you see students working on projects, and some examples of projects that were completed where an art history and politics student learned from scratch how to 3D print, how to design things in Tinkercad, in Doodle 3D, and she project managed 6 people, and they 3D printed outlines of 60 countries for a bio art project. And then there was a media studies student who was designing jewelry, belt buckles, and sunglasses, and we made it easier for him to learn about technology. And then we had a media studies and CS student that used 360 and 180 cameras to create a theater play with augmented reality elements. So there was a really good learning experience there as well. The link to the play is at the bottom of the slide. And so this is an example of what's affordable. External GPU is somewhat affordable, more affordable than the full system. Raspberry Pis are affordable, and with this technology, people can be taught how clusters are built and how they work. Also, when you build something like this, it feels like a toy, but it's a real learning experience. It teaches you about command line, distributed computing, sharing keys, version control. This is another example of a typical Asya slide where I like to provide information for people to follow up on certain concepts, like, for instance, the concept of power over Ethernet, where you don't need to have a separate power adapter for each Raspberry Pi. You can power it literally via the switch that it's plugged into. And I've seen time and time again how that blows students' minds, and they get engaged with technology and realize that it doesn't have to be difficult. And this is the list of other technical toys we have. There's a Merge Cube, there's an Intel Compute Stick, which is an addition of a TPU or a special processing unit to a Raspberry Pi that doesn't have a built-in graphics card or a GPU. And that's a meeting speaker with 360 ability to record in 360 and also spatial sound recognition so that it focuses the camera on somebody who speaks. And lots more in this slide that I don't have time to get into, but you can Google all these. These are really fun. And some of the projects that were in our lab were Autodoc Vina, which is used in chemical modeling. that can run on Raspberry Pi clusters. So that was a really good use case. And then one of the students was studying race in VR. Is it represented? Is it represented well? Some of these are obvious answers, but that was the step number one for the student to actually get engaged and start creating something in a new medium. And this was a slide from meeting something called Miami Posse. At Pomona College, the students get a chance to visit the college before they come to study. So during the summer, these groups would come through and I would meet with them and tell them about the lab and high performance computing and sneakily try to recruit them so that they come work for me when they're on campus. And I like telling the stories in pictures. So this is more data center tours. There's my colleague Angelina helping me at the job fair, talking to students. There's Max showing people Raspberry Pis, I believe. And there's Lindsay and Nicole holding a hard drive in their hands for the first time. And there's Zintan installing parts into a laptop. And I like to see people happy. I like that everybody's smiling. And there's more examples here. There's Ariane working on one of her art history projects. And there's Kevin printing in a resin 3D printer. And I'll briefly go over interesting use cases that we're working on right now. There's a psychology project that is studying decision-making. There are several projects in economics that are dealing with things like topic modeling and sentiment analysis. We are working with GIS with various different software packages and orthomosaics. In physics, we have some really interesting projects with nuclear fusion simulations and quantum irreversibility. And in computer science, we are using virtual GPUs. And in environmental analysis, we're using sensors and queues and NoSQL and graph databases and data visualization. And our museum wants to build an augmented reality app because not everybody can visit it, or at least it's limited for the time being. So that way we can maybe bring art to more people. In terms of the future, summer research just kicked off. It's been an incredibly busy time. The college is going to be partially teaching online, so I'm helping out my team to figure out things like tablets and apps that run on tablets. 64-bit Raspberry Pi is out, so that's probably the most exciting thing that happened lately for me. I'm looking forward to 128 cores in a single 2-socket server. I'm experimenting with Optane, which can be used for memory or storage. I'm like to build science gateways specifically for economics, but maybe other disciplines, to make access to high-performance computing easier to people that don't necessarily want to spend time learning command line. I'm continuing to train undergraduate students in my job, and I'm participating in the high-performance community diversity efforts. And this is second to last slide, I think. So students programming the DJI RoboMaster using Python. Everybody is engaged, and they're not even realizing they're learning skills they can use later in real jobs. And then a group of students created an app called HPC Ponder, and that will be my last slide. I'll tell you a bit more about that. And this is a What is Human class where people are exploring technology and trying to see how it relates to us as people, as humans. And a picture of our lab jam-packed with equipment. And that's my last slide. This is the app that was created by the students because we believed that in order to be successful at something, you have to have the language of that area. So this was our attempt to onboard students as quickly as possible, but by giving them access to words that they will use in their job, and explanations and links to where to learn more. So I encourage you to download it. Right now it's only iOS, but it's coming in Android as well. And contact us and let us know what you think. And I'm going to pause here with, I think, 1 minute remaining.